Today's lesson is section 3.3, day 2. It's about finding more derivatives using the derivative rules, and we're going to write the equation of a tangent line. And we'll also be computing second, third, and fourth derivatives. First, we're going to do a little work with numerical values. And we are going to have two functions. One's called u and one's called v. And we're going to say that they're both differentiable at x equals 3. So we're given these four values of the two functions at 3 and the two derivatives at 3. So we have u and u, derivative and function, and we have v and b, derivative and function. So we're going to find four different derivatives here using the product rule and the quotient rule. Let's start with the derivative of u times v. This is what we need to use. U times v, that's a product. We're going to use the product rule because it's a product. So remember what the product rule says. It says the derivative of x equals u times v prime plus v times u prime. So we know all those values because they're right up here above the problem. So the derivative at x equals u, which is 2, v prime, which is 4, v is 1, and u prime is 5. So 8 plus 5 equals 13. That's the answer to number 1. Next, let's do the quotient rule because we have a quotient, u divided by v. So let's take our quotient rule and apply it. The quotient rule says that we take vu prime minus uv prime over v squared. And really your denominator and numerator matter. This v squared is always the denominator, the v is the denominator, the u is the numerator. So that will make a difference, especially when we do number 3. So let's plug in our numbers again, like we just did on the other one. V is 1 times 5 minus u is 2, v prime is 4, and v squared is 1 squared. So here we have 5 minus 8, which is negative 3 over 1. That is equal to negative 3. Okay, now we have the third one, which is another quotient rule. So we're going to use the same quotient rule. The problem is our u and v are mixed up. So our new quotient rule for this one, because we have to start with the denominator u squared down here. So we're going to do uv prime minus v and u prime. Okay, so let's plug in these numbers then. U is 2. So we also have 2 squared down here. 2 times v prime, which is 4, minus v times u prime, which is 1 times 5. So 8 minus 5 is 3 over 4. So that is our answer to number 3, where we have v over u. Notice how number 2 and number 3 are not the same. Okay, now last but not least, the derivative of two terms being subtracted is just the derivative of one minus the derivative of the other. And we have a constant multiplier, 2 and 4. So v prime is equal to 4, so we have 2 times 4 minus 4 times 5. 8 minus 20, that equals negative 12. So that's our answer for part 4. All right, let's move on to the next topic, which is higher order derivatives. This slide is mostly about the notation. Remember, we learned that first derivative can be f prime, y prime, dy dx. If we have a second derivative, which is just taking the derivative of the first, We have 2 prime marks, double prime, a y double prime, and we also have numbers inside our dy dx. D squared y over dx squared. All right, and notice how this looks with third derivative and any n derivative. You put the number in next to the d and then above the x. All right, third derivative, we have 3 prime marks. Third derivative, nth derivative, whatever number you want to put in there and whatever derivative you want to take. And that's how our notation goes for these. Let's do an example taking each derivative. So the first derivative, and I'm going to do this the shortcut way, which after taking derivative yesterday you should be a little bit familiar with. 5 times 2 is 10x to the 4th. 4 times 3 is 12x cubed. 3 times 7 is 21x squared. 5 times 2 is 10 x's. And then plus 9x to the 0, which, remember, x to the 0 equals 1. And the derivative of negative 2 is 0, so we don't have to put that down. All right, that's a derivative, first derivative. How about a second derivative? Told us to find 3 of them. So second derivative, 40x cubed minus 3 times 12 is 36x squared. These 2 multiplied together are 42 x's minus 10. Be careful not to drop some of your exponents. That can often happen when you have a little cute derivative like this. All right, last but not least, our third derivative, 120x squared minus 72x's plus 42. Hopefully my multiplication is good there. But you get the idea of first, second, and third derivatives. Now, last, we're going to find the equation for the aligned tangent to the curve. Remember, again, when we find a line tangent, we need a point and we need a slope. Okay, so we're going to do this a little bit different way. I could use the quotient rule for this, but we are actually going to use the power rule to find this derivative. Let me show you how we are going to rewrite this equation before we start to use the power rule. First of all, we're going to take 6x squared over 5x squared minus 4 over 5x squared. These two this is just the same function rewritten. I've split it up into 2 parts. All right, so let's take these 2x squareds are going to cancel out, right? So we have 6/5. We still haven't started taking the derivative yet. Minus 4/5. Now remember, when you have an x in the denominator, that's the same as x to the negative 2. So now we're going to use the power rule on this. So, and take our derivative rules. The first derivative. Well, the first derivative of, oops, this should say minus. The first derivative of 6/5 is 0, because that's a constant. So the derivative is 0. Minus 4/5 is just a multiplier. Now, we're going to take negative 2, because that's our exponent, and multiply it by x, and then we're going to subtract 1. So we have x to the negative 3. Okay, so negative exponents, you do the exact same way that you do regular exponents. All right, so let's rewrite this again, and we need to plug in x equals 2 because we're really looking for the slope. So we have negative 4/5 times negative 2. Oh, let's just multiply those together. That's 8 over 5. And x is going to equal 2. Remember, x to the negative 3 is the same as 1 over x cubed. So I'm going to put x cubed down here in the bottom and plug in a 2. So we have 8 over 5 times 2 cubed. Well, we know that 2 cubed is the same as 8. So this equals 1/5. Our slope, therefore, is 1/5. All right, so last step. Take your point and your slope and write a line. The point is 2, 1. And there you have the equation of the tangent line. That's the end of our lesson today.